All right, I'm back, still on page 269. We're gonna finish this and then probably call this video quits and come back because it's kind of like a transitional page. So let's do that. So step one, I gotta factor this, 2x and x. And all right, I always like start out that way, like what multiplies 2x squared. Now I just have to think about what multiplies to -5 and then check the middle term. So I'm going to want to go with +5 and -1. So that'll give me 2x squared. I'll get 10x minus x is 9x. And then, yeah, so good. We're going to number line this or sign chart, which I would prefer to say. So -5 and 1/2. It's a quadratic that opens up. Like the thing inside the absolute value, ignore the absolute values, would just look like this if I graphed it, which means plus, minus, plus. I use that a lot, right? So each of them is a first degree term, which means there has to be a sign change at those. That's polynomial stuff from like algebra 2. So each is first degree. Plug in -1 billion, and you're definitely going to get a positive, and then you just go sign changes across. It's not always the safest thing to do, but it always works if you do it right. All right, and then I'm going to just write this. I'm going to do the 3 branches, 2x squared plus 9x minus 5 when x is less than or equal to -5. The opposite of that here, when x is between -5 and 1/2. And then back to the original 2x squared plus 9x minus 5 when x is greater than or equal to 1/2. I always choose to put the equal to on the like original u, but you know, you can actually do whatever you want. It doesn't make a difference. So is this question any different? This question's a little different, and it's different because of the same thing that will plague us forever. You can't divide by 0. So since you can't divide by 0, x could never be -3, no matter what happens. Cannot be. But I look at it and I see 2 factors. I see an x minus 2 and an x plus 3. We need to worry about the ratio of those. So what happens is you find the 0 of everything. So I'm going to put the 0 of everything on a sign chart. So I get -3 from the denominator. I get +2 from the numerator. Okay, now it's the ratio. -1 billion. -1 billion minus 2, definitely negative. -1 billion plus 3, definitely negative. The ratio is positive. So now everything is from a first degree thing, so I'm going to have sign changes. And I could do it that way, and I think that's how I'd prefer to do it. But if you keep testing, plug in 0, you get -2 over 3, that's negative. So negative. We're ignoring the absolute value when we do this. Plug in 1 billion, it's pretty clearly going to be positive. All right, and let's write it. So you can never get -3. That's an issue. In fact, a better organized person probably would have done this. Like you get an open circle there, never going to happen. It's actually a vertical asymptote, but like on your sign chart, it would be an open circle. All right, can we do this? I think we can do this. All right, so it's going to be x minus 2 over x plus 3. That's a weird 3, but I'm going to roll with it. And that is when x is less than -3. Okay, you can never get -3, so I'm not going to include it on the next one. I didn't include it on this one. Just, you never include it. The opposite of this, bad 3. I can't make 3s anymore. -3, that was a good 3. It's like, I'm trying to make them too small, I think, when I write the function. To 2, and then back to the original. When x is greater than or equal, because you can have 2. You can't have -3 because it's a 0 of the denominator. X equals 2 is a 0 of the numerator, and those are always fun. So this greater than 2. All right, and let's do this one. This just combines kind of like the last 2 problems, basically. So -4, woo! -4 will never work, but I need the 0 of everything. So first I'm going to, still an absolute value, I'm going to factor. X plus 2, x plus 5. My algebra 1 teacher, Miss True, like phenomenal. Like I was one of those people that I took algebra 1 in like 7th grade, failed it because I didn't do any of my assignments, took it in 8th grade, Basically the same scenario. I just did not believe in doing assignments when I was in middle school because I had older siblings and they were like, middle school doesn't matter. And I'm really glad that my teachers failed me because I don't know what would have happened if no one had had those standards. But man, freshman year, Miss True, out like I don't know, like she was the movie version of a math teacher, like yells at you, you got to do it her way, or but man, can I factor because of her? Like she would just give us hundreds of problems, and we just had to factor them. Like that's my memory of it. I'm sure it wasn't that, but whew, it's true. I tried to write her a letter, like to thank her a long time ago, like not so long after I was out of high school, but it turns out she'd already passed away. And that was sad. Um, but so like, if you have a teacher that you want to thank, I'm not talking about myself because like whatever, I'm just a video. Don't wait. Thank them. I wish I could do that for her, but couldn't. Tried. Too late. -5, -4, -2. Let me warn you about like the number one mistake that I see people make on these, which in my mind I probably almost just made. Make sure you put these numbers in the right order on your sign chart because as soon as they're in the wrong order and you're trying to like test a value, it's not going to work. And then you get like these things and you try to like graph something and you're just like, how is this even working? And then suddenly you realize like, oh, -5 is less than -4 or whatever. So like the order really matters. All right. I'm going to test negative a billion. Negative a billion is going to give me a negative, a negative, and a negative. 3 negatives make a negative. So it's going to be negative. Let's do that good student thing where we say that -4 is not an option. Everything is first degree, so there's just going to be sign changes everywhere. So I'm just going to do that. So it'll be pluses. It'll be back to minuses and pluses. You can test the last one kind of easily, like a billion is going to be positive, positive, positive for sure. -3 is not impossible to check. It's going to be a negative, a positive, and a positive. So I'm plugging it in like -3 plus 2, -3 plus 5, -3 plus 1. The key is we don't care what the number is. We just care overall. Is it a positive or a negative? So that's why I like just keep saying it's positive, 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 like not saying the actual number. So let's write this. This is going to be bad. It's got 4 branches. You could do the thing where you combine it into 2 and just say it's like this thing for here or here, and then this thing for here or here. I'm not going to do that because I don't really like it. Though I am going to do a weird thing. I'm going to say that g of x is x squared. I'm doing this to save space and time. So I made it be the inside of the absolute value. And then what I'm going to do is I'm going to say that f of x is, it's going to be the opposite of g of x when x is less than -5. It's going to be g of x when x is between -5, and let's include that because it's the original u, which is where I like to include that. X, -4. -4 will never work, so we don't include that. The opposite of g of x again, -4 to -2, and we can include -2 or not. I'm going to not include it. I'm going to include it on the next one, but it doesn't make a difference. Sometimes I just include them the first time they show up, which is safer because then you never forget. But for some reason in these notes, I've decided I'm going to do it with u instead of the opposite of u. I don't know. You got to pick your things. And then when x is greater than or equal to 2. Okay. I'm going to stop this here, and I will be back in the next video. We're going to transition. We're going to start doing what I really think of when I think of like doing limits. So I'm excited for it. I hope you will be when you see it, and I will see you then. So till we meet again.